Let's go over an example for this week's discussion quiz. Question 1 is a free response question, meaning that you're going to be graded on not just your answer, but also the work that you provide. Given this function f of x, can we use the limit definition of the derivative to compute f prime of x? No points will be awarded for using the derivative shortcut rules, like for example, the power rule. I'm going to start by writing down the limit definition for the derivative. If you want to find the formula for f prime of x, it is the limit as h goes to 0 of f of x plus h minus f of x all divided by h. So this is a formula that you need to know for this class. What I'm going to do is take this equation and substitute in x plus h, subtract off the function itself, and then divide by h. So to start that process, we get the following. This is the limit as h goes to 0 of. In place of the function f of x, I'm going to substitute each x with an x plus h. That looks like the following. 10 times x plus h squared plus 3 times x plus h, then minus 20. Next, you want to subtract the entire function. Since this equation has multiple parts, I would definitely put a parentheses because you want to subtract the entire function, but that function is 10x squared plus 3x minus 20. And we're dividing by h. So for my next step, I'm going to write down this entire expression, but I'm going to square out the x plus h, distribute the 3, and then also distribute this negative. That process will give us the following. This is the limit as h goes to 0 of. It's going to be a gigantic fraction, but we have 10 times x plus h squared is you square the first term, you square the last term, and you get 2 copies of the middle terms when multiplied together. So that's x squared plus 2xh plus h squared. If you distribute the 3 into the parentheses for the next piece, we get plus 3x plus 3h minus 20. And then you have to be careful to distribute the negative to all 3 terms here. And that will give us minus 10x squared minus 3x, but then plus 20. And we're still dividing by h. Next, I'll distribute the 10. I'll copy all of this down, and then we'll cancel any like terms. So this is the limit as h goes to 0 of, okay, so that's 10x squared plus 20xh plus 10h squared plus 3x plus 3h, keep going, a lot of stuff, minus 20 minus 10x squared minus 3x plus 20 at the very end, all over h. So again, that step was I simply multiply the 10 to every single term. It's at this stage where I would try to cancel as many terms in the numerator as possible. So I have a 10x squared and a 10x squared. One's positive, one's negative. Those cancel. Let's see. We also have a positive 20 and a negative 20. Those cancel. And then we have a plus 3x and a minus 3x. The only stuff that is left over is going to be the 20xh, the 10h squared, and this 3h. I'm going to copy that down on the next slide. So here's the expression after I didn't write down all the terms that did cancel. The next thing we'd like to do is try to cancel this h from the denominator. And I can see there is at least one h in each term in the numerator. So the strategy here is let's factor out h from every term in the numerator. In doing so, if you factor out h from here, you're left with 20x. If you factor out h from 10h squared, you get 10h. And then you have a plus 3 at the very end. Once this is factored, you can cancel it. And now the denominator is just equal to 1. Therefore, I don't need to write this divided by 1 or those h's. I'm simply going to put, okay, this is the limit as h goes to 0 of 20x plus 10h plus 3. We're now allowed to evaluate this limit by putting 0 in place of h. So I'm just basically going to substitute a 0 right there. That gives us 20x plus 10 times 0 plus 3. 10 times 0 is 0. This is 20x plus 3. And in fact, that's the answer to this problem. The derivative of the function that we started with is 20x plus 3.